Alright, so in this video we are going to talk about some uh, radical expressions. So I'm going to teach you how to simplify radical expressions. So let's say, for example, we have fourth root of uh, 32x to the power of 9, y to the power of 5, z to the power of 12. So in simplifying radical expression, you call this radical expression because it has a radical sign, the fourth root, that is a radical symbol. So in order to simplify this, you need to um, make every exponent a multiple of 4. Because it's fourth root, so it's a multiple of 4. If it's cube root, then you make every exponent a multiple of 3. So here, that 32, um, let's transform it first. 32 can be written as 2 to the power of 5. 2 times 2 times 2 times 2 times 2. That's 5 2's to multiply. It will give you 32. And then we'll rewrite everything first. Okay, so let's continue. So it's not yet a multiple of 4 except for z to the power of 12. But we can rewrite this so that we can have a multiple of 4. So we can write 2 to the power of 5 into 2 to the power of 4 times 2. So we have one multiple of 4 and the others are not. And then for y to the power of 5, we'll separate y to the power of 4 and times y. While z is having exponent multiple of 4 already, it's divisible by 4, which is 12. So we don't need to do anything with that. Then we can take out now the 2 to the power of 4. So what you will do is just divide the exponent by the fourth root. So 4 divided by 4 is 1, so we can put out the 2. So it becomes 2 to the power of 1, or just simply 2, times, so we're done with this. Next is this, y to the power of 4. So we again divide the exponent with the root. So 4 divided by 4 is 1, so it's y to the power of 1, or just simply y. And then for z to the power of 12, since we can divide 12 divided by 4, it's 3. So we can put out the z as z to the power of 3 because we divided exponent 12 divided by the fourth root, or 12 divided by 4. So it's 3. So what's left inside the radical symbol? We will rewrite this again. Z cube and then fourth root. So what's left inside is this one, the 2, the y, and there's no more z because it's taken out. So we are going to create a smaller fourth root symbol. So that's it. 2yz cube, fourth root of 2y. So we cannot take out this 2 and y because it's not having a multiple of 4 in its exponent. So that is already the simplified form. Next, let's say we have fifth root of x to the power of 12, y to the power of 4, z to the power of 24. All right, so since it's fifth root, we are going to make every exponent a multiple of 5. So for the x 12, we're going to make it x to the power of 10 and separate the x squared. So if you combine it back, it will become x to the power of 12 because you add exponent. 10 plus 2 is 12. For the y to the fourth, it's impossible for us to have a multiple of 5 exponent because it's lacking 1. So we'll just leave it there. Cannot do anything with that. For the z, we can make it z to the power of 20 and then separate the z to the power of 4. So we at least have a multiple of 5, which is z to the power of 20. Then we can take out now, we have x to the power of 10. So 10 divided by 5 is 2. So we're going to divide exponent. So what's the quotient? 10 divided by 5 is 2. And then we're done with this. Y, we cannot take out the y because exponent is not divisible by 5. The z to the power of 20, we can have that. 20 divided by 5 is 4. So z to the power of 4. And then for the z to the power of 4, we will just leave it there since it's not a multiple of 5 as well as the x squared. Now let's rewrite the remaining. So x squared, y to the 4th, and z to the 4th power. So this is the final simplified form. And then, alright, so we don't have much space, so we're going to go back to our on top, and then we can do this space. Okay, so another example, we have cube root of 9x squared times cube root of 6x squared. So here you are not going to simplify directly because it's a multiplication of two radicals, and it is the same cube root, so we can just multiply what's inside and then copy the radical sign. So you just multiply 9 times 6, that is 54. And then x squared times x squared, that's x to the power of 4. And then just copy the radical symbol. So next is we're going to simplify the product. So since it's cube root, we want each exponent to be a multiple of 3. So for the 54, we cannot identify directly the value, so we will just separate it first into 9 times 6. So we'll just separate it again. For the x to the 4th power, we can write it as x cubed times x. Okay, so let's erase the previous example. And then let's write the 9 as 3 squared. And then the 6 into 3 times 2. Then copy the x cubed and x. So erase the previous example. Okay, so we have 3 squared and 3. We will combine that so that we can create a multiple of 3 exponents. So it will become 3 cubed times 2 times x cubed times x. So that is what we are after, to create a multiple of 3 exponent. And then we can take out now the 3 cubed because it has exponent of multiple of 3. So the exponent will be divided by the root. 3 divided by 3 is 1. So we can take out the 3 as 3 to the power of 1, or just simply 3. Also the x cubed, so we're done with this. X cubed, divide the exponent. So 3 divided by 3 is 1. So it's x to the power of 1, or just simply x. Then we will just leave the 2 and x there because we cannot take it out since it doesn't have an exponent that is multiple of 3. So we'll just leave it there. a cube root of 2x. So that is the simplified form. All right, how about addition of radicals? So let's have an example like 3 squared of 20 minus 6 squared of 125 plus 5 squared of 45. Okay, so when you are adding or subtracting with radicals, what you want is to make this inside the radicals the same. So, and you have to keep in mind that the radicals must be the same power. So they are all square roots, so there's no problem with that. Now what you want is inside the radicals must be the same as well. So we're going to simplify that. Uh, let's break it to 20 times, no, 4 times 5, sorry. So let's make it 4 times 5. And then this is, that is 25 times 5. And here it's 9 times 5 because it's 45. So we have 4 is 2 squared times 5. And then 25 is 5 squared. And then 9 is 3 squared. So what we are after is to leave this 5 inside the square root so that they are all the same. And this 2 squared, 5 squared, 3 squared will be taken out. Since they all have multiple of 2 exponent, they can be taken out since the radicals is square root. So we're going to take it out. The exponent will be, since it's 2, 2 to the power, 2 divided by 2 is 1. So it's 3 times 2 to the power of 1, or just simply 2. And then leave 5 inside. Minus 6 times, so 5 squared, square root of 5 squared, or just divide the exponent. 2 divided by 2 is 1, so it's 5 to the power of 1, square root of 5, plus 5 times, the same with the 3 squared, so you put out the 3, square root of 5. So it's all now square root of 5. So we are going to simplify further. 3 times 2 is 6. 6 times 5 is 30. And 5 times 3 is 15. So after that, since it's all the same radicals, it's square root of 5, what you're going to do is just combine these numbers at the side of the radicals. So combine that 6 minus 30, that is negative 24. Then copy the square root of 5. And then negative 24 plus 15 is negative 9. So that is the final answer. So the idea there is you cannot combine if the radicals are not the same, including inside. Even if they are all square root, if what's inside the square root are not the same, you cannot combine these values. So unlike here, it's all square root of 5. So that is the time that you can combine 6, negative 30, and positive 15. Next example is we are going uh, to rationalize radicals. All right, so let us clean this first. Okay, so let's rationalize um square root of 7 over square root of 3. So if you say rationalize, meaning you are going to make this denominator uh remove the radical symbol. So there's no problem with the numerator, but the denominator must have no more radical sign, meaning there's no more square root, cube root, or fourth root, and so on. Alright, so let's continue. So to remove that square root at the bottom, you are going to multiply it by itself. So that it becomes square root of 3 squared, because 3 times 3 is 3 squared, or 9. Right? And then on top is 7 times 3, and that is square root of 21. So square root of 21, and then at the bottom it becomes 3, because the exponent 2 and the square root will be cancelled, so it's only 3. And then for the numerator, it's square root of 21, so you just leave it there, because the purpose of rationalization is to remove the radical sign at the bottom. So that is the rationalized answer. Next is we are going to uh, rationalize again, but this time it is a bit difficult. 4 over square root of 6 plus 5. So this time you cannot just simply multiply it with square root of 5, because it is having two terms. So if it's like this, you are going to use its conjugate. If you say conjugate, it's opposite operation. If it's plus, then you do the opposite operation, which is minus. But still, you just copy everything. So you have to keep in mind that whatever you multiply at the bottom, you must be doing the same on top, because it's the same as you are multiplying to 1. So that means you didn't change the value. You just change its form. The same way on top, this is also equals 1. Square root of 3 over square root of 3, that is 1. So you did not change the value of the given, you just change its form, because any number multiplied by 1 is just itself. Alright, so let's continue. So using the idea of difference of two squares, remember that a squared minus b squared is equal to a minus b times a plus b. So look at this, it's plus and minus, which is the same as this. So this is plus, this is minus, so we can apply this. So that means this is square root of 6 squared minus 5 squared. On top, you can just distribute the 4. 4 square root of 6 minus 4 times 5 is 20. So we just distribute the 4 here. So there's no problem on top, because what we are our concern here is the denominator, that the square root will be gone. That is the main purpose of rationalizing a fraction. So let's continue. We'll copy the numerator. We cannot do anything about this. Here at the bottom, square root of squared of 6. So it's the same as square root of 6 times 6, 36. Because it's square root of 6 times square root of 6. Here minus 25. Then let's copy first the top. Gonna do for now on top. Let's just solve at the bottom. So square root of 36 is that is no, sorry. Yeah, so it's square root of 36 and then minus 25. And then 4 square root of 6 minus 20 over 6 minus 25, that is negative 19. Now there's no more square root at the bottom, but there is negative sign, so it is not good to write a negative at the bottom. So we always transfer that on top. So it becomes negative 4 square root of 6 minus 20 over 19. So we just transfer the negative sign of 19 in the numerator. And that is allowed to do. So we're going to distribute a negative sign, so it becomes negative 4 square root of 6 plus 20 over 19. And this is the final simplified form.